Welcome, everybody. Today we're going to be working on the Unit 2 exercises part 2, and we'll be working on 2.7, 2.8, 2.11, and 2.32. In order to see those exercises, you can just simply click on the assignment header, and then you can pull down the exercise descriptions in this document. You might already have it from the previous set of exercises, by the way, but sometimes I reattach it just because. So I'm going to go down to 2.7 here, and then I'm going to copy this information that says basically write a program that prompts the user for a radius and then prints the area and circumference of a circle with that radius, and then the volume and the surface area of a sphere with that radius. So kind of an interesting, little conundrum, right? Like to solve. Now, all right, let's talk formulas here. First thing, I mean, everybody's got like the area and circumference of a circle formula memorized, right? No, actually, believe it or not, I feel like a mathlete. These are really basic formulas, and you would actually have them memorized. But like, if you're a normal human being, which that's like 99.9% of us, it's like, what? I know it's got pi in there somewhere, but that's about it, right? And truly, what I always recommend to my students is, for example, formula for area. No, notice, thank you, Google. Area of a circle, right? There's your formula. So the area of a circle equals pi times r squared. Okay. If I want the circumference of a circle, there it is. The circumference equals 2 times pi times r. Okay. Second question. So there's the formulas and where to find them. And you know what? Let's do this. Let's first, I'm going to do in my spider here. I got all the old exercises open. I'm doing a close all from the file menu. I have a new file created here. So let's just go ahead and do a save as right off the bat. I'm going to have to do a little bit of file management to start because I'm managing this from within the program. So I have a 2026 Spring folder. I'm going to make a new folder for Unit 2, Part 2 exercises, and all the work's going to go in there. All right. This is exercise 2.7. I'm going to label it accordingly, X27, and save it. And then I'm going to take the instructions that were given in the document, and I'm just going to paste them up here at the top for easy reference, right? So I can refer to that. Now, you'll notice what I did here from the last time I taught this is when I went out to Google and saw those formulas, I copied them in right into the comments here. And notice even the symbol for pi I copied over. I was like kind of impressed. Right, that's kind of a cool little feature there. But pi is a mathematical value, and that's kind of another one of those things you might want to Google, and that's where I was going. The value of pi, right? Now, math geeks, and I used to be one of them, by the way. I used to be able to recite the value of pi to like 10 decimal places. And I still sometimes get pretty close. I know it's 3.1415926, and then I kind of forget. Right? There is a song, yes, absolutely. There is a Pi Day, March 14th, that's the thing too. But pi is what they call a mathematical constant, and often people will abbreviate that number to 3.14, or notice 3.1415926,535, and those are usually considered pretty accurate levels of it. But truthfully, pi is a number that's a constant, that's a ratio of, spherical objects, basically, or circular objects. And that decimal goes on non-repeating off into infinity, right? It's a weird number, right? And when we do mathematical calculations, if they're really crude ones, 3.14 is adequate. If you're trying to land a man on the moon, though, and pi comes into the formula, 100 decimal places might be a thing you want to use. I mean, think about this. You're sending somebody millions of miles away. If your calculation is slightly off, they might miss the planet altogether and land on something else. So like the accuracy does become important. Now, the reason I mention this, right, is one way that you can solve these problems is when you come up with these formulas in your program, and some people will do this, they will just hard code 3.14 or 3.1415 or some variant of that, maybe rounded to calculate the value of pi. And in some cases, that's okay, right? What I always remind people is like what scale are you working on? Are you calculating, a circle-sized patio in your backyard, or are you calculating the circumference of Jupiter? You're going to use different precision for each one. What you can do, though, and this is what I'm going to do in the program, is I'm going to import from our math library, I'm going to import pi. So pi exists in the standard math library, and what it does is it brings in the exact infinite value of pi in for calculations, at least as far as I know, right? You guys catching this? So here's the import statement. And so wherever in your formula you want to use pi as a value, you will simply replace that with this two-letter combo. If you're uncomfortable with that two-letter combo and you want to make it just the letter P, you can also just say P equals pi, right? If you want to do that, that's on you, right? I'm not going to do that. Or some people just say pi equals 3.14 and whatever. And if that's your approach for doing the program, fine. You'll get pretty close to the right answer. But once again, I'm going to always have you consider when you're doing math, you got to think of the scale of the problem and what accuracy you need. And if you're not sure, then whoever your mathematician is would be aware of that. All right. So the program instructions say, write a program that prompts the user for a radius. Okay. So we want to write a prompt that's going to prompt the user. So we're going to say, I'm looking for a radius. I'm just going to call my variable r. If you want to call it radius, go for it. But my thinking is these formulas, radius is always expressed here as an r. So that's what I'm going to call it here. All right. So we're going to prompt the user. So I'm going to do an input. I'm going to say input. And check this out, you guys. I'm going to do a \n, right? That's my escape sequence. I like to push my prompts down one line before I start them. There you go. That's how you do it. And then I'm going to say, enter the radius. Now, truthfully, we don't know what units we're talking about. It could be inches, it could be meters, it could be miles, it could be millions of miles. Who knows, right? That's irrelevant. Right? Just enter the radius. And then we know we're going to do math with this. Also, we know we're going to multiply against or divide with pi. And pi is an infinite number of decimal places number. It probably makes sense to convert it to a floating point. So I'm going to wrap the float function around the input to convert the input from the user directly to a floating point number. So they might type 5 and return it to 5.0. Or if they're scientists, they might type like 5.67925 or something like that, right? They might get really precise. We don't know. But either way, we want it to be a floating point number. Why? Because the precision of the math would be all that much higher. So, all right. So if you want to label this, by the way, so I know some people are into that. This is what I had last time. Read the radius from the user. Then the next step is to compute these formulas that we captured up here and turn them into code, right? So I'm going to say here, and I apologize, I'm copying from the other screen. So we're going to do the computations. So the one thing that we're going to compute is area. So I'm just going to use the letter A, right? And that calculation is pi times r raised to the second power. So I'll do star star 2. Or I could do pi times r, the same difference, right? Yes, it is. I sure would. So that's the area calculation. You wanna label it? I mean, you can do that. So you can just say area calculation. Then we want to calculate the circumference. That formula is 2 times pi times r. So I'm going to go 2 times pi times r. And then that, of course, is that's the circumference calculation. So there's our formulas. All right, so that gives us bullet number 1. Okay. And okay, I know there's a bullet number 2, but even in the interim, we could come down here and start displaying the results. So we could start doing our output and just test the first 2 formulas. We don't have to do all of it at once. So I'm going to show you how I put together my first output statement here. So my first output statement, this is kind of interesting. I'm just repeating back to the user what they entered, right? And I'll tell you what, in the console program, users kind of appreciate that. You know, it's kind of like enter your name, and then it comes back and says, hello, Joe. You know, it acknowledges that it received the information. So given a radius of, and I notice my formatting command in there, and I'm putting it out to 4 decimal places. Okay, why 4? That was just an arbitrary choice. Now, once again, if we're doing calculations like this, it all depends on the scale of what we're dealing with. You know, if you're drawing a circle in your backyard, like I said, you probably don't need 4 decimal places. If you are, calculating the size of the sun, you probably need a lot of decimal places. It's all about accuracy. So that's very subjective, like what that value is. I just went with 4 last time. So I'm just repeating back the information. Then in much the same fashion, I'm going to do print statements and you can kind of guess where these are going, right? We calculated A, we calculated C, and then I'm just going to print those out. And notice here's the A, here's the C. Both are also expressed to 4 decimal places. I'm deciding to be consistent. And if you choose a different number of decimal places, that's fine, but I would still say that decimals are important here. Now we can run this code and see how it works. I'm going to hit the run button. I am going to, oops, sorry, wrong panel. I'm going to click over here and zoom in just a tad. All right, so I'm going to enter the radius. And let's just put in a really simple number like 5. Given the radius of 5, say 4 decimal places there, the area of the circle is 78 point whatever, and the circumference of the circle is 31 point whatever. So once again, if we were dealing with inches, do we need all those decimal places? No. Probably 2 decimal places would be enough. If we're dealing with millions of miles, those decimal places are hugely important. And then notice up top here in this little bonus panel, I'm on the Variable Explorer, and you can see the fully expressed decimal that's listed here. And notice the pi that it brings in from the math library, you can see the level of precision of it. How many decimal places is that? Oh, I don't know. It's a bunch. So that's part 1. The second part is to compute the volume and surface area of a sphere with that radius. Right, so there's the goal. And then if you go out to Google or whoever is your search engine of choice or your AI agent, you'll come back with these formulas. So the volume of a sphere is 4 divided by 3 times pi, the radius cubed, not squared, but cubed, right? So that goes out in 3 dimensions. And then to determine the surface area of the sphere, it's 4 times pi times r squared. All right, so now we just have to convert those formulas. So I'm going to follow suit. I'm just going to use, well, I'm going to use V for volume, right? I'm not going to use A for area, but it's because it's really surface area. So I'm going to use SA for that, just so you guys know. So for V, we're just converting the formula here. We're going to say 4 divided by 3 times pi times r to the 3rd power. Do I need parentheses or anything here? No, because division and multiplication are all on the same level. Doesn't matter what order they happen in. Well, according to the PEMDAS rules, multiplication will happen first, by the way. So if you really want to get particular about it. Exponents, multiplication, and then the division. So that's the formula. For surface area, I'm going to call that SA, right? Then once again, I'm just converting the formula. 4 times pi times r, and this time the r is squared. And that gives us the surface area. Fascinating formulas, and it's fascinating that people took the time to figure this stuff out, but helpful. You know, if you need to paint the surface area of a sphere, you need to know how much paint you need and, you know, whatever. All right, so there is the formulas, and then I have 2 output statements put together. These are, of course, both in F-string format. So here comes the solution for that. Right, and these are simple output statements. Like, and in truth, you know, once we have, you know, that radius put in, right, that radius then would apply to the sphere. So let's run the program. So this is the complete solution there you see on the screen. And let's put in the same number we used before. And you'll notice that the volume of the sphere, given a radius of 5, whatever the units are, is 523.6, basically. And the surface area of the sphere is 3141593. Oh, isn't that an interesting number? Like, I almost chose the radius size on purpose so that the surface area calculates to pi. You guys picking that up? Kind of. See, math is really, really weird that way, because when you look at it and you try to understand it, it hurts your brain and it doesn't make sense. But what I'll tell you about math is it's actually a clunky human way to describe what naturally and beautifully happens in nature. And we're trying to describe it with numbers, you know, and there's patterns that form. And I think this is really what's fascinating about math is patterns form. And I'm showing you a little hack there, right? That if I use the radius of 5 and I determine the surface area of that sphere, that works out to be pi. Right? So that wasn't an accidental number choice. But you should be able to put any radius in there of any size, and this will calculate. So for example, if I decide to enter a radius of, like, you know, some like ridiculously large number with a ridiculously large number of decimal places, and I have it do it, it will handle it just fine. Those of you also studying Java, right? And Joel, I'm looking at you because you're in the classroom, right? And I know you're studying it. When we get to these really large numbers in Java, like these are really large numbers, we have to use special variable types to capture and output them, right? We have to have long numbers, as they call them, and there's exponential notation. Python doesn't kind of care about that stuff. It's really weird, right? So it'll just do it. And then if I wanted to, and I'm just going to say, just for example, if I want this to go to, I don't know, 20 decimal places, so I'll run this again and we'll put in, some big number again, like that. Notice I can make that happen. I can force those decimal places in there. Isn't that weird that it works out to 0 on that one? Yeah, no, that's pretty weird. So that's the solution for exercise 2.7. Everybody cool? It's got this one. Another thing you can do, and I'm just like throwing this out there, when you're working with those formulas here in Google, you can actually drop values in and it'll show you what the answer is. Okay, why this is super cool for programmers? Because it's a double check. The other way you could do a double check, you could use a calculator, or like data analytics people, a spreadsheet, right? One of those types of tools. But the fact that you can look up any formula you want on Google, and most of the basic ones, and this is considered a basic one, they have like an on-screen calculator where you can drop in a value and can kind of see like, was my program coming up with the same output? Oh yeah, it is. Okay, I'm fine. That's kind of the thinking. So, and then, the thing I will repeat often when I teach programming is when you're given a formula, and don't just assume it's working right, you always have to double check it. Once it's double checked and you're assured it's working correctly, it will always work correctly. There's no reason to go back and double check it again. The only reason I can think of is maybe if you want to increase the precision of it for some reason. All right. Interestingly, when I added like all these decimal places here, like way up on top here, the variable explorer, I don't know how well you guys can see this, but like this number I'm pointing at right now, actually went out, it took this 1.75 or whatever, times 10 to the 17th power, and so it'll actually start to express it in exponential notation if you actually look behind the scenes on it. So it does go to deep levels of precision. All right, our next exercise here is exercise 2.8. So I'm going to go back to the document here, wherever, okay, there it is. Just took a moment to load. And this one says, once again, very similar. Write a program that asks the user for the lengths of the sides of a rectangle and then print the area and the perimeter of the rectangle and the length of the diagonal. Now, this sounds a little bit familiar, right? Because we did the diagonal calculation, so we can borrow that math again. So let's do that. All right, so let's get this one going. And I'm going to start a new file here, doing my save as, saving it as exercise 2_8. I'm going to blow away the comments up here. And in fact, I'm going to blow away all this stuff here. And this is how I did it last time. I just typed it. This is what I typed in. All right. How do you get the area of a rectangle, folks? Do we need to look that up? Length times width. Right. What about the perimeter? 2 times the length plus 2 times the width. 2 lengths plus 2 width. Yeah. Or you're putting parentheses around length and width. All right. So 2 times the length plus width. Yeah, that works too. If there's parentheses around it. So those are pretty easy. And then the diagonal is back to the a squared plus b squared equals c squared, the Pythagorean theorem, right? And just refresher, we did that last week. So we can borrow that. So maybe I shouldn't have closed all my old exercises. Not a big deal. We can easily recreate that. Right. Now, when you do the square root for the diagonal, you do have the option, of course, to do the from math import the SQRT or square root function. So you can do that if you wish. And then I'm going to put in the or here, or you can raise it to the 0.3 0.5 power, right? So you can go star star 0.5, same difference, right? So your choice. I'm going to use the square root approach. All right. First thing we're going to do is read in the length and width from the user. All right, let's have this discussion. On the previous exercise, we converted to floating point. Is that appropriate here? Or are we dealing with whole numbers? Well, here's what I'm going to tell you. What is that rectangle? Are you just like measuring a little rectangle on your wall? Or are you measuring a football field? Or better yet, are you measuring out the parameters of state boundaries? You know what I'm saying? You don't know the scale, so to be safe, you should convert to a floating point number. So here's what I did for length. I created a variable called length. I prompted to enter the length. Notice the backslash n for an extra blank line there. Converted it to a floating point and stored it. And you can guess pretty quickly that width was basically the same. Enter the width, convert it to floating point, store it in a variable called width. Then we're ready to do some math, right? And if you want to label this, right, you want to do that input thing. This is input, right? What comes after input? Processing. And in this case, we will know what is the processing. Compute the area, perimeter, and diagonal. And remember, you can look up the formulas on Google if you don't remember them. It's not an embarrassment to say you don't remember them. Right, it's okay. All right, area is pretty simple, right? So if we do area equals length times width, right? We go back to like the fertilizer problem on that one, right? Pretty basic. The perimeter is basically walking around the outside of a rectangle, right? How long is that? Well, two sides are the same length, two sides are the same width, right? So Ray's calculation, you can lay this out a couple different ways. This is the way I did it. I did 2 times length. See, let's spell it right. 2 times length plus 2 times width. If you decided to add length and width together and then multiply by 2, that also works. This is just a factored version of the equation. It doesn't really matter. Generally, the formula is 2 times length plus 2 times width. All right. Then we have the diagonal. If you don't remember that formula, you can go look it up. But it is the way that I always build it is I do it from the inside out. I do length squared plus width squared. And then I put all of that in parentheses. And then take the square root. Or if you wanted, you could take all that and raise it to the 0.5 power. That works too. Right. And of course, the mathletes know that trick and normal humans don't. And eventually, you guys will be mathletes just because of the virtue of programming, or at least sort of mathletes. All right, so there's our diagonal calculation. Then we're left with the final part of the program, which is doing the output. Right, so here's the output part, which is just show results to users. Here's my 3 output statements. I think with these, you can pretty much guess them, right? I'm just taking the words, we're putting them on the screen. Really kind of the only wrinkle here is I got a backslash n to move it down 1 line. I'm rounding to 2 decimal places. Is that appropriate? Once again, the answer is it depends on the scale that you're working with. That's a quick and simple answer. And then all it takes is a little runtime here. So let's hit it. Right here, enter the length. Let's put in a real basic number. So the length is 10. The width is 5. And I'm using small numbers that I can handle because like just from that, think, okay, what's the area? What's 5 times 10? 50. What's the perimeter? 10 plus 10 plus 5 plus 5. 30. Yeah, thank you. Yeah. And then the diagonal, whatever, somewhere in between 5 and 10, right? That's a pretty safe. And actually, it's going to be longer, right? It's going to be a little bit longer than 10. Right? So that's why I use numbers like that, because that way I can just kind of calculate them in my head, or you can put them in a calculator really quick. And then once you're assured you're getting the right answer, right? Now I can pump in much larger, numbers and be assured that it's calculated correctly. So that's exercise 2.8 solved, folks. All right, we are, believe it or not, at the halfway point beyond it already. So let's do a 5-minute break. I'm going to pause the recording here, and then we'll come back. We got 2 more exercises to work on. And I don't think that those will take a super long time. So, all right, I'll see you guys in 5. All right, welcome back from break, everybody. We are going to move on to the next exercise, which is exercise 211. All right, I already copied the instructions for this, so I have them ready to paste. So I'm going to make a new file, same routine here. I'm doing my save as. This is x2_11, and then zooming in here on the code panel, and then scrolling here on the console, kind of give us a blank slate. Up here in the comments area, I'm going to paste, the instructions. And it's basically asking this: write a program that asks a user to input the number of gallons of gas in the tank, the fuel efficiency in miles per gallon, and the price of gas per gallon. Then print the cost per 100 miles and how far the car can go with the gas in the tank. All right, kind of a goofy little thing, but also kind of a really useful calculation. I don't know if you guys ever have been in this situation. Like if you're a truck driver, or you don't have a lot of money and you're trying to calculate if you got enough gas money to go up north for the weekend or something like goofy like that. These are kind of calculations that you do. And this is the kind of thing, like when you go out and you buy a car, I'm just kind of giving you guys some advice. If you're driving pretty far to work, the fuel efficiency of your vehicle can really have a huge financial impact on how much money you spend on fuel. And a really great example, and I'm going to use like some of my vehicle info that I know about my vehicles as examples. But like, I have a few different vehicles, and I have some that are highly inefficient and some that are very efficient. And so for example, like I got a vehicle that has a towing package on it and a big motor. So like if we hook up like a boat or a trailer and hauling lumber or something like that, it can handle it, but it gets absolutely horrible gas mileage. And then I have a little commuter car that's manual transmission and diesel that gets an insane amount of gas mileage. But these are just like weird little calculations. Just like, what does it cost you, for example, to drive to work? It is kind of a calculation. And one of the reasons I'm so thankful that I work mostly from home now is I save that money all the time, because I used to drive down here to Racine. Think about this, an hour drive, and I would do that 4 or 5 days a week. Man, that's a lot of money. It's a lot of money and wear and tear and all that. And Melanie, I see that you have your hand up, your question.
I just wanted to see if you could share your screen.
Oh, great. I have all this like video footage of my face now. Thank you for reminding me before.
Yeah.
And then maybe when I post the video later, I can edit all that stuff out. Or take this screenshot that we can see now and overlay it over my face while I'm talking, because I really hate looking at myself real large, by the way. All right, so let's get down and try to solve this problem then, because I think this is a kind of a practical problem um, that you guys might find helpful, by the way. All right. Now, the first part of the prompt says, write a program that asks the user to input. How many things are we asking them for? Three different things, right? How much gas in the tank? What's the fuel efficiency of your vehicle? And what does gas cost, right? And I'm going to give you some tips on all those things, whether you like it or not, I guess. So let's do the first part, which is to get the inputs from you guys. So here are the prompts that we're going to give to the user. So like we're asked to get the number of gallons of gas in the tank. So what I did is I typed this. So I typed this little thing. I call the variable tank amount. You call it tank if you want, whatever. And enter the fuel capacity of the vehicle. Okay, this is a really kind of interesting stat. But I know that if I walked up to like 20 people on the street and said, how much gas can you put in your car? Most people have no clue. If you ever travel a long distance, especially going through the desert or somewhere really, really remote, you want to know this piece of information, right? I know for all of my vehicles what they hold. That's not true. My new Highlander, I'm not really sure what it holds. I think it's like 15 or 18. But you should know the fuel capacity, because that way when you look at, oh, I only got a quarter tank of gas, you can kind of ballpark like how far you can go. So knowing that is pretty important. All right, so then the next one we're going to prompt for is the miles per gallon, right? So how far can your car go on 1 gallon of fuel? Okay, once again, a lot of people don't know this off the top of their head. When they're shopping for a new car, you go into the car dealer, right? They got stickers on the car, and they'll give you like an average, and they'll tell you what the city mileage is and the highway mileage is. And then they get the average is like what you can really kind of expect to get out of it. And once again, most people do not know the answer to this. The only ones that really kind of pay attention are the people buying brand new cars. Most people that buy used cars, and I put myself in that category, and I'll never pay for a new car again, kind of thing. Don't think about it, because they just want a car that runs and stops, right, and is safe, right, and doesn't look like my car, basically. But this is a really handy stat to know as well. I have vehicles that get mileage as poor as 15 miles to the gallon, right? Utility vehicles. But man, when I'm hauling something, I got a bunch of people moving around or a boat or something, that's what I want to use, right? Because it's more powerful. And then I have my little, like I said, 5-speed manual diesel Volkswagen Golf. It's been hacked a little bit too. That can get almost 50 mpg, right? It's not a hybrid, by the way, which is crazy, right? And that thing only has a 13-gallon tank. So do the math on that, 50 times 13. 600 miles, folks, on 1 tank of gas. Drove all the way back from Florida with 2 fill-ups. Crazy, right? If I take my big Toyota, I'd be stopping like every 100 miles or something, right? Because super inefficient, paying a fortune in gas. Right? All right, so that's kind of my little thing there. You can just go out to Google, by the way, if you don't know, like what's the fuel capacity of like, I don't know, a 2006 Honda Accord. It'll tell you the fuel capacity. It'll tell you the MPG, and then you can throw in your own vehicle if you want to do comparisons. And then we're going to do, well, actually, I'm going to copy paste this in. We'll do another prompt for the price of gas. All right. Now, where you get your gas can have a big impact on what you pay for it. All right. A couple of consumer tips here. I'm a Costco member, save a lot of money at Costco on gas. Like if it's like, I'll just throw it out there, like 239 over at Quick Trip, it's probably gonna be like 205 at Costco. I did get gas at the Kenosha Costco yesterday, and you know what? I didn't even look at the price. Sometimes I make note, but usually it's cheaper than most places, right? Woodman's has pretty decent prices on gas too. And then every once in a while you find a gas station. You know where you pay the most for gas? Along the interstate. Yeah, they upcharge you. Why? Because you're not going to drive into town to find the cheap gas station. You're just going to take whatever's at the side of the highway. So knowing that can make a difference too. All right. What's that? Sam's Club? I used to do Sam's Club too. The reason I switched to Costco mostly is because of their food selection. I like the Costco food selection better than the Sam's Club. You got more organics, whatever. Same difference. All right. So now we got to do the math. Now we got to do some calculations. So if we're looking at the cost per 100 miles, okay, so that's one calculation. And the other calculation is, and how far the car can go with the gas in the tank. Well, kind of an interesting thought. All right, so let's do I'll come up with a variable. I'm gonna call it cost per 100. And then here's my calculation. I'm gonna take 100 and divide it by my MPG. Start there. And then I am going to put parentheses around this, even though technically I don't think it's really needed. Whatever that result of that calculation is, I'm going to multiply that by the price of gas. So for example, if my MPG is 50 miles to the gallon, when I divide that MPG into 100, what's the result? I'm using 2 gallons, right? Times whatever the cost of gas is. So that's telling me, what does it cost you to drive 100 miles? Now, calculation I might do, like from my house to this campus, it's like 38 miles. So I could calculate like what it cost me to come to campus. So you could change that 100, right, to 38 if you wanted. I'm just kind of giving you ideas here if you want to calculate what it costs to get to work. And then to figure out how far I can go on a tank of gas, I'm going to call that one distance. That's like how far can you go? And then I'm going to take the MPG and I'm just simply going to multiply it by whatever's in the tank or the tank amount. So if I have 50 miles to the gallon, I'm using a really round number because it's easy to calculate, and I have 10 gallons, I can get how far? 500 miles. See what we're thinking there? All right. Then we want to do some output here. So here's the output portion of it. All right. I'll start with a print command. And yeah, I'm doing a little copy paste in here. So blank line, \n, right? And then I'm going to say something like this. I'm just going to close out the whole statement. It takes $ cost per 100 .2f, so I'm formatting it to do decimal places. So how much fuel? So it's going to give me an answer like 13.25 of fuel to drive 100 miles. You know, that's just an example. So how much fuel does it take you to get there, right? And no, excuse me, how much money does it take you to get that 100 miles? That's the calculation that we're looking at. Then the second statement that I put in is how far I can go with the fuel in the tank. All right, so there's the second one. And notice with this one, I didn't round it. Let's think about it. MPG is usually expressed in whole numbers, right? The gallons, well, all right, that might be a decimal, right? I got 13.5 gallons. So if I take a decimal and multiply it by a whole number, what do I get? A decimal. It's going to give me a decimal answer anyhow. All right, well, let's run this. This is the solution, by the way. Not a lot of code. Notice that it's like 6 lines, 7 lines of code. So enter the fuel capacity of the vehicle. So I'll do one example here. I have my one Toyota, my older one. It's got an 18-gallon tank. The MPG, if I'm lucky, right? If I'm lucky on a good day driving on the highway mostly, I might get like 18 to the gallon. It's a big V6 towing package. Let's call gas 225 right now. Super cheap, by the way. So it takes $12.50 of fuel to drive 100 miles. So if I had a 100-mile round trip to work, it's $12.50 a day I'm paying just for gas. And then on a full tank, so using up all 18 gallons, I can go 324 miles. Not bad. But when I compare it to my little Volkswagen diesel Golf, remember manual and diesel and slightly hacked, by the way, it's got the AGR valves been modified, right? It's only a 13-gallon tank, right? The MPG officially, I think, is like 48 on the highway. Yeah, it's crazy. The manual transmission really helps a lot in capacity. And then you do the same cost. Take a look at the difference. So which one do you drive to work? Yeah, it's $4.69 of fuel to drive 100 miles. So think about it like this. If I live in Milwaukee and drove to Chicago, I could drive back and forth to Chicago with 10 bucks a gas. Okay, okay, and that's not really fair because diesel costs more. So I should run the program. What's a fair price for diesel these days? So that's not a fair comparison. Let's do that. 13, 48, and I think diesel's like 320 a gallon. All right, 667. So 13 bucks, 14 bucks. But look how far I can go on a tank of fuel. That is just crazy. Right? It also gives you a little bit, so why are big trucks? Why do big trucks have diesel motors? Because diesel is a lot more efficient than gas. Here's the question I always ask, because now I have a vehicle that's a hybrid, right? So it's gas and electric, right? Same model as my other Toyota, but I get like 25 to the gallon with that because it's hybrid. What if they took the diesel and combined it with hybrid? They do that in Europe. They don't do it here. But diesel's going away in consumer vehicles. But they don't, because it's a little dirtier, unfortunately. But a lot more efficient financially. So it tells you why all the big trucks are diesel and not gas. Let's move on to the next exercise, folks. The next exercise is 232. I'm going to go ahead and start a new program file here. Let's do our save as. So X232. 32, yep. Let's paste in the instructions. Zooming in a little bit. So here's the instructions. It says, read the total book price and the number of books. And I guess this is really kind of out of context, isn't it? Let me find it in the document here because I think there's more explanation. And of course, you're always welcome, by the way, to do all the exercises on that document if you wish. That was cruel. I didn't make you do all of them, but I don't know what that would teach you. It says the following pseudocode describes how a bookstore computes the price of an order from the total price and the number of books that were ordered, right? So you walk into a bookstore, you buy a book, right? You pay the price of the book, there's sales tax on it, and then you might have the book shipped, right? These are like things that you might do. And I want you to think about like what's being presented here. What we're really talking about is kind of like point of sale stuff, right? So like this is kind of like retail sales. Right? You buy a product, you add tax to it, you add shipping to it, and then you charge your customer a total. And like this sort of calculation or this sort of problem really is kind of like first steps of writing like almost like a cash register program, if you guys want to think about it that way. But these are things that could happen on a website. So like if you're a website person and you're doing e-commerce, you would have to take all the products and add them together and add the sales tax and add the shipping and yada, yada, yada. Or if you're running a cash register program, and think about this, all the cash register or point of sale systems that you interact with at the grocery store, at the fast food chain, at the gas station, whatever, those all have software written behind them too that handle these calculations. Somebody figured out that the pseudocode for solving the bookstore problem is read the total book price and the number of books. So where are you reading them from? Well, if you're at a point of sale, they're scanning them, right? Or if you're ordering them online, the website's doing it. Or if you're talking to somebody on the phone getting their order, it's like, well, how many copies do you want? I want 2, that kind of thing. So that we're going to get from the user. We're going to prompt the user. We're also noticing a couple of pieces of information here. So the next one is compute the tax or the sales tax, right? And they're saying here it's 7.5%. By the way, is that 7.5% going to change? No. So you might consider that a constant. Remember, Python doesn't really do constants, but we can declare values to be, assumed or implied constants by how we name them. And then you also have the shipping charge, which seems to be a flat rate $2 per book. That also seems to be a hard-coded value. And so we're going to call those givens. Now, when you write your program, you can hard code those numbers into your code, or you can save them as implied constants, and that's what I'm going to recommend you do. And then they tell you how to calculate the total thing, which is the price of the order is the sum of the total book price, the tax, and the shipping charge, and then print the price of the order. So they just want you to give, it's like, what's it going to cost me? Here it is. All right, so that's the general thing, and that's what I translated here into Spider up at the top. It's just that pseudocode. All right, so let's start by declaring the constants. All right, and remember, in Python, constants are implied. So now, just to kind of refresh this concept, tax rate and shipping per book are truly variables. But by naming them all cap and separating the logical words with underscores, we're implying that those values should never change. Why do I store these at the top of my program and name them? Because if I was to write a really complicated cash register program that maybe had a couple hundred lines of code, sounds like about right for most cash registers, the tax rate would propagate to a lot of different areas below. And then if I want to update the program because the tax rate changed to 7.6, I just change it in one spot and the whole program fixes. That's the why. Otherwise, yes, I could just hard code the percentage and the shipping price. I want you to notice that with the percentage, I did 0.075 because that's 7.5% as a percentage, right? Remember, percentages are between 0 and 1. And then the shipping per book, I put at $2. I made it a floating point number just to be on the safe side for precision's sake. All right. Did I really need to do that? Well, you can experiment with that for yourself. For whatever reason, I decided that was a good choice. Next task is to get the inputs from the user. So first, we're going to get the price of the books. So here's the book price. So I created a variable called book price. All right. And think about prices. Prices for things are never like $5. It's like $5.49, $6.79, whatever. It's always like some odd number. So floating point, and I'm expecting somebody to enter like $24.99, right? Or in the case of textbooks, $249.99, right? Which is, I know it sounds like a lot, but truthfully, the Python book that we used to have in this class cost that much, if you were to buy it outright. So just be thankful as you take this class that you didn't pay that money even to rent it. Right? Save that money. Woo! All right, good. Next one is we're going to capture the number of books. Oops, sorry, that's not the correct statement. Now, question, we're going to do a conversion here, right? Because we're going to prompt the user, how many books did you buy? Floating point? No, that should be an integer, right? Because you're not going to buy 2.5 books. Not going to take the book, rip it, and go, here's your half. So that one's an integer. Right. Now we're going to do our mathematical processing. So we did our inputs. Here's our processing. What are the things we have to calculate? Well, it tells us compute the tax, right? Well, all right. I want you to notice up above where we capture the book price. We're not asking like how much did each book cost. We're just asking what was the total cost of all the books. So to determine the tax, I'm going to say tax equals the tax rate times the book price. I'll put a space in there. So I bought 2 books at 50 bucks. That's 100 bucks. And then I'm going to multiply that 100 times 0.75 to get the tax. Okay, that just gives me the tax though. I also need to calculate the shipping. So I'll go down a line here and I'll type shipping equals. And then how do I get the shipping cost? Well, if I look up above, it's $2 per book, right? So I would just say the number of books, num books is what I called it. And I just multiply that by the shipping per book, which is 2. So like my point with the constants is I could just hard code 0.075 here, and I could just hard code 2 here. And when we hard code values, by the way, we call those literals. The value is literally 0.075, and the value is literally 2, right? Okay. When we hard code values into a program, so Ray's asking me to repeat it for clarity, and thank you, Ray, right? So when I so instead of, for example, typing a tax rate, which refers to this value up here, I literally type 0.75 or 0.075 here. That 0.075 is a numeric literal. I'm literally typing it in, right? Not a great idea in a program because once again, if that value appeared in my program 50 times, and then somebody's like, hey, guess what? The tax rate updated. I got to go to all 50 spots and update it. Yeah, it doesn't take that much to do it. But it's so much easier if I want to propagate all the way through my program, I just come and change that number and all of them change at the same time. That's the reason we do it. So just trying to reinforce good habits. All right, we also have to calculate the total price. I'm just going to call that total and then price, the capital P there. And then how do you get that? Well, you take the book price, right? And then we add the tax. And we add the shipping. That will give us our total and it'll put it on the screen. And then really, truthfully, right? If I wanted to output this to the screen, all it says is print the price of the order. It doesn't say print the price of the tax. It doesn't say print the price of the shipping. It doesn't say print the price of the books. But then I'm going to have you think about if you go to a store and you purchase stuff and you get a receipt, you totally want to see all those things. Like 2 books at $50, this much for tax, this much for shipping. Here's your subtotal, here's your total, whatever, right? And that's how you want your receipt to look. So I always tell my programmers is like when you're considering your output, think about the fact that if this was like a cash register program, what detail would you want to see on that receipt? So I might encourage you to maybe be a little bit more verbose with your output than you might think of being otherwise. And you can do this a number of different ways. So like the one thing that you could do is you could just very simply, and I'm just going to type this manually, is I could just say print, right? Parentheses, double quotes. I'm going to make it an F string. And I'm just going to say something like the total price of the order is, and we'll extrapolate it here. We'll put a dollar sign in front of it just to be polite. We'll do our curlies, and then we'll just say total price. And you want to format it to a money format, you probably should. So we do a dot to F. And then let's run it, right? So the total cost of the books, let's use easy numbers, 100, number of books 2, and the total price of the order with the tax and the shipping is 111.50. Okay, that accomplishes it. So if you just do this, I'm good with it. You can cap it here. But here's your food for thought. If I was the customer, right, I went on a little more detail than that. So here's what I did last time is I did this. So I did a bunch of F strings here, you notice, and I had a subtotal, right? So the person bought some books. They bought a certain number of books. So I start with, okay, what was the subtotal, which is just the book price. And then I have how many books did you order? So I put the number of books in. And then I have the sales tax listed. And then I have the shipping. And then I show the total. And, and if I really wanted to be like super like ASCII arty, right? And that's kind of a weird thing to say, but I could like even put in like dividers and stuff like that, to make it look nice. And then think about how a cash register receipt looks. You could say receipt, store name, address, yada, 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 And what I'm kind of having you think about here, and what is my error here? F string is missing placeholders. Oh, yeah, I guess I don't need an F string because I don't have a variable inside of it. Yeah. So if you don't put any variables in your string, you don't need the F. Right? Would it break? No, it'll still run. All right, so let me run it now and take a look at the difference in the output. So we'll do the same numbers, right? And total cost of the books, 100. Enter the number of books 2, but then look at the output, right? All right, well, the shipping for 2 books didn't really print out all that beautifully. So that one should probably be, I don't know, something like that. But if you want to play with the formatting, look at the F string formatting document and then make it as clean as you want. But what I'm trying to give you the idea of, right, is when you are dealing with users and you're putting output on the screen, the more details you provide, the happier your users are, right? So I like to do really verbose output because being a user myself, that's what I want to see details on my receipt. Right. So play with that. You can run it again. Let me see if my little adjustments, close. You're better off using the formatting commands to get them all to line up perfectly because the ideal would be that all the decimal places, like those 2 line up okay. It looks like I needed one more spot here, right, to make it line up. All right, let's run it again. Okay, so now the money amounts are lining up okay. But you can see like kind of what my goal is here, right? Next time you guys walk into a store, this is a challenge, watch the point of sale system as they scan your products. And then if they ask you if you want a receipt, say yes, and then look at the output. And then remind yourself that some computer programmer programmed it. Like how it looks on your receipt, it's like totally a thing. And that's a job, right? You can make money doing it. Yeah, that's a thing. Totally is. All right. So that was exercise 232, and that completes basically all the homework. And we still have 6 minutes of class time left. So I'm going to cap the video here. I'm not going to record a solution for the mortgage calculator, but I'm happy to talk about it for anybody that worked on it because it is extra credit, right? So if you guys want support with that, I'm happy to talk about it. But let's call this video complete.